All right, welcome everyone, and thank you for joining us today for how to speed up software threat modeling, threat remediation, and NIST software security supply chain compliance. Threat modeling anticipates weaknesses in software that an attacker could exploit, allowing teams to implement defensive countermeasures during the software development process. But traditional manual threat modeling practices are time-consuming and inconsistent and do not scale, leaving most applications unprotected. In addition, software development and application security teams also struggle to understand and demonstrate compliance with both existing secure software development standards, such as the Payment Card Industry Software Security Framework, or PCI-SSF, or the Cloud Controls Matrix, or CCM, developed by the Cloud Security Alliance. They also struggle to understand and comply with emerging standards, such as those related to Executive Order 1428, Improving the Nation's Cybersecurity, which includes NIST 800-218, the Secure Software Development Framework. In this webinar, learn how you can take a developer-centric approach to threat modeling that can significantly speed up software threat modeling, threat remediation, and NIST software supply chain security compliance practices. So as we begin, a little bit of housekeeping here. You will receive an email with a link to the slides from today's webinar, along with a recording after today's event. Next, and very important, please ask questions. To ask a question, type your question in the Q&A box, and we'll address any questions you may have during the Q&A session at the end. And then finally, if you have a topic that you'd like to see covered in a future webinar, please reach out, send us your ideas at contact@securitycompass.com. And with that, I'll go ahead and introduce our speakers for today. Our speakers for today are Drew Coulomé and Kevin Delaney. Drew is a product leader with deep experience working with agile software teams as a developer, as an engineering lead, and also as a product manager. And Drew is really passionate about nimble and secure software development and helping organizations bring value to and maintain trust with their users. And our second speaker today is Kevin Delaney. Kevin is a passionate technical sales leader. We got some passionate guys here today with over 15 years experience helping buyers navigate and understand complex technology. Kevin is an accomplished presenter and speaker. He shows up a lot on podcasts and television and other media outlets, so you may have seen him there discussing current information security events and where Security Compass fits. And prior to joining the company in 2015, Kevin has worked in several other technical and sales capacities. He's led channel pre-sales at a SaaS startup in the data protection space. And Kevin holds a bachelor's degree in information technology. He specializes in network and security. He went to Ontario Tech, and fun fact for Kevin, he started his first software business at age 14. So thanks to Drew and Kevin for agreeing to be our speakers today. Next, we'll cover the agenda real quick here. So during our time today, if you want to, yep, perfect, thank you. During our time today, first, Drew is going to talk about a new approach to software threat modeling, threat remediation, and compliance, a new developer-centric approach, which can speed software threat modeling and remediation. He's also going to spend a little bit of time talking about compliance, and with a special focus on speeding compliance with one of the newer standards that's emerged over the last 12 to 18 months in response to Executive Order 1428, Improving the Nation's Cybersecurity. And this executive order is very much related to NIST software supply chain security compliance. And hopefully, as many of you will ideally know, this executive order was issued in 2021. It covers both threat modeling as well as secured software development practices. And according to some recent guidance published in 2022, it does require U.S. agencies to start collecting attestation letters from software vendors for critical software by June 2023, and for all other software by September 2023. So, again, since this standard requires demonstrating some compliance not only with the Secure Software Development Framework, but it has some threat modeling requirements as well. If you do not have this standard on your radar already, it's probably time to get this on your radar and start making sure you understand the requirements and what types of things your organization might need to do to comply. And then last but not least, we're going to turn things over to Kevin, and he is going to kind of bring everything to life and show how you can actionably and in a very pragmatic, real-world way, speed up your software threat modeling, threat remediation, and NIST software supply chain security compliance. Then we'll end with a Q&A session as well as talk about some next steps. So kind of with the setup out of the way, I'm going to go ahead and turn things over to Drew. Take it away, Drew.
All right, thanks so much, Marian. As Marian mentioned, I'm Drew Coulomé, Director of Product Management here at Security Compass. Thank you so much for spending this time with us today. Excited to share with you some of the things we're talking about. So what is threat modeling? Well, so instead of coming up with my own definition, I'm going to reference the Threat Modeling Manifesto, right? It's a famous document written by some of the world's best thought leaders on threat modeling and serves as the industry's North Star on the topic. So according to the Threat Modeling Manifesto, threat modeling is analyzing representations of a system to highlight concerns about security and privacy characteristics. At the highest levels, when we threat model, we ask 4 key questions. And these are like the really key things to kind of think about here. What are we working on? What can go wrong? What are we going to do about it? And did we do a good enough job? So in other words, it's trying to understand all the potential avenues an attacker could use to compromise an asset and producing an appropriate set of countermeasures that should be implemented as a result. There are many different traditional approaches to threat modeling, but they can suffer from the same set of challenges, especially at scale. The analysis phase of threat modeling is very often manual and expensive. It is dependent on costly and scarce, or sometimes even non-existent resources within your company who set up meetings, then work through diagrams, spreadsheets, and whiteboards to begin to identify threats. But even when that happens, the output is often inconsistent between practitioners. In fact, 2 subject matter experts could threat model the same application and come out with substantially different outputs. After threats have been identified, what results in terms of recommended mitigations often end up being insufficient detail and really not immediately actionable for developers to do their remediation. The ad hoc nature of how these recommendations are provided also makes it really difficult to integrate with other development tools in the software development lifecycle. And on top of that, very little, if any, consideration is given to how these recommendations intersect with regulatory compliance that your organization really is required to follow. So kind of how this breaks down, right? And this might look familiar to some of you. You might be doing this today, right? So, in this first stage of the information gathering, we're kind of like, what are we working on? What are we trying to build here? Involves a ton of meetings, whiteboarding, kind of discussion about how we want to kind of think about this architecture, what the components are trying to do, etc. Right? Then we're kind of moving into an expert assessment, right? This is often involving, in addition, to the team and other stakeholders, the security practitioner, to really analyze what could be going wrong with the system, what is it trying to do, etc. We're quickly moving on to, quickly after days, weeks, to describing our threats and countermeasures, right? So once the attacker persona kind of comes in and says, well, these are all the different ways that I would attack this architecture, defender personas might say, well, these are the things that we need to do secure. Again, this is days to weeks. And then at the end of this, how do we know we actually did a good job? Right? That's often not in scope, right? Because all of these things kind of along the way haven't necessarily been captured in any kind of way that we can analyze to say one-to-one, this has been done, etc. Right? So take a very long process. You can see how in a modern software environment, this can be fairly difficult to do at scale across all the different things you're trying to do as an organization. Given all these challenges, it's clear that existing approaches to threat modeling are kind of falling below expectations from the business. They're really outpacing what engineering can keep up with and realistically deliver on and still use best security practices. Over the past 15 to 20 years, we've seen a massive change in how mission critical software is architected and developed, getting more and more complex. Yet more organizations still depend on legacy threat modeling processes to secure them. We've gone from a single code base to layered architecture to microservices and hybrid infrastructure, which has really increased complexity considerably. Yet very few organizations have stopped to really ask themselves if their threat modeling approach has kept up with the pace of change. On top of all the engineering changes, the expectation of the business to reduce risk, reduce time to market, manage costs, and improve compliance all at the same time have never been higher. And there's a fundamental friction with the traditional threat modeling approach. A lot of organizations are realizing that DevSecOps sounds really great as an ideal, but if it's not complemented by a more developer-centric approach to threat modeling, neither the business nor the engineering teams really end up meeting their objectives, and it's very costly and risky. We have to make some trade-offs there. As the security landscape rapidly evolves, the stakes become higher. Modern engineering teams need ongoing training, actionable mitigation strategies, and the ability to self-serve on threat modeling without hard dependencies on the scarce and often overworked AppSec resources, so they can get secure code out the door faster with as few roadblocks as possible. So this is taken from an article that was published in 2021. I think it's a really great visualization of a typical scaled organization. You have in the kind of the dark blue your development teams, your kind of line developers there. In the orange, you have architects, and this little group kind of down here as a cybersecurity professional. So you can kind of quickly see for every cybersecurity professional, you might have up to 10 architects working with 100 developers total, right? So this is 1 to 100, kind of a ratio. So if your threat modeling practice, if your cybersecurity practice is really kind of making this group a hard dependency on kind of being successful, you can see how that really limits your ability to kind of scale out across everything that you're trying to do. All right. So let's talk a little bit more about developer-centric threat modeling. It's really the idea that we're looking to make it easy for developers to include security in the development process without it becoming overly complex or time-consuming. It needs to have self-service tools that can be integrated with current workflows and automatically build security capabilities as products are being developed. Such tools can work alongside the developers as they are moving through the development process. The goal is to accelerate, not delay releases. Making security a natural built-in part of the development process, something that developers are willing to include. Some key characteristics here, right? It's integrated into existing developer tools and their CI/CD pipelines. Security is built seamlessly into the development process, and it's not bolted on as an afterthought. Security training and education needs to be right when and where developers need it. We need to have efficient component reusability and threat model reusability, near instantaneous feedback, and an automated reporting process. Since you joined us today, you're probably interested in how we can support your organization in a more developer-centric approach. Well, we took a holistic look at how to streamline, automate, and take the pain out of threat modeling so it is fast, accurate, and scalable for businesses of any size. The first thing developer-centric threat modeling lets you do is identify weaknesses associated with threats within minutes. When we focus our attention on the weaknesses that threat actors can exploit, we're able to automate the advanced logic required to arrive at an accurate model very quickly. By identifying the weaknesses, but identifying the weaknesses is only one piece of the puzzle. So many organizations we've spoken to spend a ton of time trying to arrive at a prioritized list of threats, and for the most part, they do a good job. But then providing engineering with actual mitigation guidance specific to their tech stack is where things often fall apart. Developers and DevOps teams are then left to their own devices to figure out how to mitigate each threat, and that often leads to improper implementation. By leveraging a large library of actionable guidance and language-specific code samples, you can scale the knowledge of your AppSec team and have confidence that the most recent best practices for your tech stack are being followed across the org. When it comes to communicating these controls and recommendations, a developer-centric approach has to be just that, developer-centric. So it's focused on integrating actionable guidance with step-by-step instructions directly into the developer's workflows by natively integrating with tools like Jira, Azure DevOps, and Jenkins. This is critical for acceptance amongst development teams because let's face it, no developer wants to spend their day crawling PDFs, wikis, spreadsheets, or other third-party tools for how to do their job. We also enable meaningful collaboration between compliance, security, privacy, and engineering by unifying the common metadata those teams share and mapping prescribed controls out to common regulatory frameworks. Where this approach also really excels is its ability to quickly and effectively report on an application security posture or provide data that is required by auditors and regulators. No more cell phone photos of whiteboards, long email chains of different versions of spreadsheets, or audio recordings of intake meetings. The developer-centric approach checks all the boxes for your organization to stay secure and most importantly, prove it. All right, so how does SD Elements help speed this up? In the information gathering stage, well, in traditional threat modeling, this equates to the security team asking the software teams, like, what are we working on? Existing best practices and methods call for diagramming sessions led by security experts to cover all the relevant components, which, as we mentioned before, right, can really kind of break down at scale. SD Element supports information gathering in a couple of different ways with an emphasis on consistency and scalability. Most customers gather info through templated surveys that are designed to make it easy for software teams to provide answers to key technical information and critical components used to build products. Most sophisticated and mature customers have automated parts of this process by populating most of this information through our SDE platform, through our APIs and out-of-the-box integrations. We are also able to launch a support for, we're just about to launch support for generating baseline diagrams that help security teams and development teams collaborate on security by visualizing the risks in their system. When configured properly, it allows an organization to quickly gather critical information on technology used across hundreds of product components in no time. All right, so a little bit of a comparison here between the traditional approach and kind of what we're doing here. When you're trying to engage with any type of subject matter expert, whether it's a lawyer, an accountant, or in this case, a security architect, every process more or less looks something like this, right? The expert starts by gathering information from you about your situation. They use their professional judgment to assess the information that you provide. They provide recommendations, and then often at the end, they will provide reports and help validate that you followed their recommendations correctly. This is why professionals like this are so vital to an organization, and there never seems to be enough of them. Let's see how we can apply that approach to threat modeling and see how SD Elements fits in as well. In a traditional threat modeling process, the information gathering stage usually involves the product team and developers explaining their system with diagrams and whiteboards. Depending on the complexity of this system, this can take a very long time. With SD Elements, information gathering is automated through our configurable, easy to understand survey in under an hour. The expert assessment and recommendation stages are the most time-consuming parts of traditional threat modeling. It requires critical thinking, expensive experts, and lots of focus on where the assessor thinks like an attacker and all the possible ways that can exploit a system. SD Elements automates this using its wide content library and advanced decision engine to instantly determine which threats are applicable to the system that you're modeling and how to ensure the system is built according to compensate for them. SD Elements provides the added benefit of providing testing tasks as well as integrations with static and dynamic analysis tools to validate the controls have been implemented properly. This is part of the process that is often not in scope for traditional threat modeling. All right, moving on to threat remediation. Right. So traditionally, once threats are identified, corresponding and required countermeasures are often documented. In many organizations today, that is still done in a manual, time-consuming way using spreadsheets or homegrown tools. Developers then have to parse through these spreadsheets, figure out which countermeasures they need to implement, then implement them, and then go back to the spreadsheet and mark them complete. This process is very time-consuming and feels very bolted on for developers. An automated developer-centric threat remediation provides a better way. SD Elements gathers information about your project, and based on the information gathered, it automatically generates a threat model diagram, uses an advanced decision-making engine to automatically identify risks, threats, and potential weaknesses. To identify threats, weaknesses, and required countermeasures, SD Elements draws on an always evolving and expanding content library that contains regulatory standards, thousands of recommendations, code samples and test cases, and even just-in-time training. With thousands of recommendations, including code samples and requirements, we're really able to kind of get the right content to the developers at the right time to kind of really assess them and correctly remediating the weakness. All right, so here's kind of a screenshot of how this looks from a developer point of view, right? So the developer has received this item in Jira. It really translates required countermeasures into recommendations and security controls, which are then seamlessly delivered to Jira and many other issue trackers. Here you can see how developer receives the required countermeasures to implement in a step-by-step guidance right within their working environment. All right, also in the issue tracker, SD Elements doesn't just tell you what the countermeasures to implement are, it also provides specific developer-friendly how-tos and code samples that have been validated by the Security Compass research team. Also included are right next to the rest of the content are these just-in-time training that you can click on. These are basically short videos that kind of give more context about what's going on here and ways to think about remediation and other things to consider. And I think we'll get to see potentially some more of this in the demo by Kevin later. All right, and then finally, SD Elements also tracks security task completion, integrating with testing tools like Veracode, Checksmarks, and Micro Focus Fortify. Developers can see if the implemented countermeasure passed testing. Application security teams can also quickly see countermeasure implementation status using automatically generated reports. All right, so we're going to talk a little bit about the software supply chain security compliance and kind of get an example of how our tool can help with compliance as well. All right, Executive Order 14028. This was released last year in May. The order was a response to the growing number of cyber attacks on supply chains and critical infrastructure. These incidents, right, famously the Colonial Pipeline, SolarWinds, etc., really were being targeted towards the government's software and supply chain specifically. EO 14028 is intended to improve the security of the software used by the U.S. federal government. Firmware, operating systems, applications, and application services, for example, cloud-based software, as well as products containing software. This executive order directed the National Institute of Standards and Technology to identify existing or develop new standards, tools, and best practices for complying with these standards. All right, so how would this work in a more traditional approach? Well, the first thing that you would need to do is like read through the entire standard. It's quite lengthy. You need to identify the required security controls and then document the required security controls in a spreadsheet or another way of capturing it. And then you need to ask the specific developers working on the right areas to implement the controls by reviewing the rows of the spreadsheet and then typically adding some sort of notation there, some verification that they did this. And you can kind of see from this traditional approach, not very automated, not necessarily very efficient, and certainly not developer friendly. Again, kind of like more of that bolted on kind of experience. So when you look at the amount of time and effort required to comply with a new standard, it can actually be dramatically reduced using an automated developer-centric approach supported by a team of application security experts. Using this developer-centric approach, relevant standards that apply to the software component under development can be selected, right? So selecting this in the survey, for instance. A threat modeling diagram can be automatically generated, showing the required security controls or countermeasures, and then that can be delivered right to the developer in the current issue tracking system for implementation, right? We just looked at an example of how that would look in Jira, right? So here it is for compliance as well. Once implemented, developers can get feedback on if the control was correctly implemented. And application security teams can also quickly see using automatically generated reports that show both positive and negative attestations specific to the required standard, which in this case are standards and requirements related to EO 14028. Here's an example of what this looks like in our reporting interface. All right, talking a little bit about our content library. SD Element's vast library delivers relevant content to the development teams with the ability to add customer-specific content if you need. One of the biggest factors that led to an increase in productivity for both security and development teams was due to the reduction in product security requirements development time. Interviewees noted their organizations decreased the time spent developing security requirements for products by 90%. Prior to the implementation of SD Elements, teams could schedule multiple meetings between security, risk, and compliance teams to understand which requirements are applicable for their products, and further meetings with development teams to understand the technical architecture and data flows in an application. With SD Elements survey templates and library of existing security and compliance requirements, the ability to automate key workflows reduce the efforts here significantly. I know this is a bit of an eye chart, but this is an ever-growing list, and you kind of see a very wide coverage, a great baseline of broad coverage for you to leverage. All right, and with this, I wanted to hand it over to Kevin Delaney, our Director of Solutions Engineering, to show you this in action.
Awesome, thanks, Drew. Okay, so I'm just going to switch over to that screen here. And hopefully you're able to see me. I'm gonna put myself up in the top right here. There we go. Okay, so we're gonna go through and in a kind of condensed way, we're gonna see in action some of the things that Drew was talking about, and we're gonna start by modeling a sample application in SD Elements for the purpose of trying to understand its threats and countermeasures that need to be addressed in the development process. When we go to answer that first question, as Drew kind of alluded to, around what are we working on, we describe that to SD Elements in two ways. I'm going to start with the first way now, which is where we answer a survey, which is going to provide SD Elements information with the characteristics of our project. What are we working on? How is it composed? What are the programming languages in use? Things like that. Somebody with good technical knowledge of a project is going to start by answering this question. So is this a Java web app? Is this a .NET web app? Is this maybe an embedded device, for example? For the purpose of the demo, I'm just going to call it a Java web application. We do have, as you saw in that last slide there, we do have a lot of different domains of content. It's not just what you see in this list, but this kind of just gets the survey started with things that we would commonly see from a Java web app, for example. I'm not going to go through the whole survey process here, but this is a highly configurable and adaptive survey that, again, somebody with good technical knowledge of a project is going to take about 20 to 30 minutes to answer. And they're going to provide some information about the architecture of the app and what type of application data does it handle. So does it handle health data, or is this a financial application, for example? Does a consumer provide cloud services? From a deployment perspective, are you using any of the new infrastructure as code tools that Drew highlighted our content recently added? Do you use Amazon Web Services? If so, do you use IAM or Route 53, for example? Every time you check one of these boxes in the survey, under the hood, SD Elements is going through our broad expert content library and figuring out all of the appropriate threats, weaknesses, and countermeasures that need to be considered while this app is being built. So fast forwarding through kind of the platform and language features and functions, we're just describing what is our application doing. When we go down to compliance requirements here, we can choose the jurisdictions that our application is actually being deployed into and needs to consider the laws of. So for the purpose of the demo, let's go ahead and choose USA. And when we go down to the NIST section, we have the option for the NIST 853 compliance. That's something that we've had in the product for a while. But you'll also now notice that we have the Executive Order 14028 here for both the critical software and software verification standards. by checking those boxes, that is now going to bring some additional content into scope, as well as enable reporting, which I'll show you near the end, that's going to allow us to understand what is our 14028 posture for critical software for software verification. When you're comparing a traditional manual process to what SD Elements is able to assist with, this is super, super powerful. So that's the first step in describing the system to SD Elements. And again, it doesn't take too long to go through. It's really customizable. So if there's things that that your company isn't using, very easy to kind of take these questions out and really make it your own. But now what we'd like to do is kind of describe it in the form of a diagram. So if we wanted to make a threat modeling diagram that represents this system that we're building, we're going to start with a blank canvas. As soon as we arrive, we're going to basically have the option of starting to draw ourselves, or let SD Elements and kind of the smart engineering under the hood start to figure out where our building blocks are. So if I click generate a diagram, you're going to notice we're going to put some of those things that we answered quickly in the survey right on there. So Amazon Identity Access Management, Route 53, we can then drag additional components on if we know that there's certain database types or certain other servers or users that we want to represent as part of our threat model. We can easily drag those onto the canvas and rename them. We can draw zones that will allow us to put certain trust boundaries together that that are going to impact the data flows and how data is flowing in between the different components of your application. And really, you can use this to articulate to your various teams internally the structure and architecture of their application. So if looking at the characteristics that have been described in the survey doesn't quite do it, they can see the visual representation here and they can collaborate on it, which is very helpful in the threat modeling process, obviously. Now, you'll also notice we've got this red tab over here that's going to show us our threats. This is a prioritized list of threats that have been identified based on the characteristics that we described to SD Elements. And as we click through them, so exploitation of trusted identifiers or leveraging race conditions, for example. Well, actually, we're not going to do that just yet. That's gonna navigate me away. But we're kind of see what the different threats are and the weaknesses that are potentially going to be in scope as a result of the threat being identified. So when we go ahead and save our diagram, continue to survey. Now, SD Elements has figured out that this project is a critical application because we said it's in scope for EO 14028. That means we have a compliance regulation we have to abide by. There's no option that we get in terms of the level of rigor that we have to go into in software development. So SD Elements applies a risk policy. That means that there's a certain bar that has to be met in order for us to be confident that this application is ready to go to production. This is highly configurable, so you can choose what defines critical, high, medium to your organization, and that way you're not working on more or less than what you need to. So we've answered the survey, we've drawn the diagram. Let's take a look at the threats list, for example. So the threat list is actually mapped out to Stride. So if you are a organization that has used Stride-based threat modeling before, this will look really familiar to you because we can actually filter this prioritized list of threats by, let's say, just spoofing threats, for example. And that might include, as it filters through here, we'll say exploiting trust in the client. So we'll get a description of what the threat is, link out to CAPEC from MITRE if you're looking for like a more technical explanation of it. And then the related weaknesses and countermeasures for exploiting the trust in the client are going to be listed here. So we can see there's a weakness for information exposure or URL redirects to untrusted sites. And then these are countermeasures that need to be completed in order for this threat to be resolved. These can be assigned out to users or to groups. It's very easy for you to kind of go through and understand the relationship between the threats, weaknesses, and countermeasures here. Now, one thing that makes SD Elements different and makes it really developer-centric is the level of detail that we go into with the countermeasures that we prescribe out to developers. So when I go to the countermeasure list and I take a look here, I get a prioritized list of actionable tasks that need to be implemented in order for all of the weaknesses and threats to be resolved. And let's jump over and take a look at what one of those looks like. let's take this one here, for example, T20, which is generate unique session IDs and reset old IDs after authentication. When I take a look at this task, I'm going to get an explanation of the weakness. What is this potential software weakness and why should I care about it? We'll link out to the common weakness enumeration from MITRE if you want the more academic explanation. And then there's a solution. Plain English, give this to an experienced developer. They're going to look at this and know what they need to do to make sure they're handling sessions properly. Now, the goal of that is to make sure that people aren't going out to Stack Overflow or Google, potentially untrusted sources for guidance on how to implement security controls. We also do that by kind of arming developers with these just-in-time training modules. So for example, we said this was a JSP application. We can actually take a 5-minute module on how to manage sessions properly in JSP right here. So there's no need to think back to what you learned in that e-learning like 8 months ago. You get the 5 minutes that's relevant right when you need it. And on top of the just-in-time training, we also have code samples. So if there is a something that you're not sure how you want to start implementing, or maybe your company has a best practice, you want to put your own code samples in here, those can all be delivered right through SD Elements. But we do ship with a big library of them right off the bat. These are known, trusted, good code samples. They're royalty-free. You can take them out and use them in your application. It's really easy to do. So countermeasures go out to developers. This interface is nice and all for the developer if they want to go in, but ultimately developers want to work out of two places. They want to be in their IDE, so where they're writing code, and they want to be in their issue tracker, which is Jira, for example. So we actually have integrations with tools like Jira and Azure DevOps and version 1, where we will actually take these countermeasures, put them right into the development backlog. So we can see that generate unique session ID task along with the just-in-time training, the code samples, everything is put right here into a Jira ticket. So really, developers don't even need to log into SD Elements if they don't want to. We just populate their Jira backlog with the countermeasures that are going to be in place. And oftentimes they're one-to-many. So if you have several different compliance regulations that you have to abide by, well, proper session management is going to be included in a whole bunch of them. Don't create a whole bunch of tickets saying, okay, well, make sure we do it properly for the executive order, and we also do it for 853, we also do it for PCI. We have one-to-many relationships for how our regulations work. So it reduces duplication of effort and makes sure that developers have everything they need to do it right the first time. And then as soon as they're done or finished, whatever your completion state is, you mark it as done, and it's going to be marked as complete in SD Elements as well. It's an automatic sync so that whoever is responsible for the security and compliance posture of the project don't need to go like Slack developers or start digging through Jira. SD Elements is kind of the single view that's going to show the current state of every project that's in their purview. So this is really powerful. This is basically the easiest way for you to start threat modeling at scale and actually make it actionable. The whole "what are we going to do about it" question. This is what answers that. What are we going to do about it? We're going to implement these countermeasures. And then that fourth question, which is how good of a job did we do? There's a few different ways that we can represent that. From a threat modeling perspective, we see a lot of our customers use this weakness summary report, which is going to outline all of the weaknesses that have been identified with the project in question and show us what we're currently doing about them. So for example, we have a weakness around clear text and unencrypted transmission of information. We explain what the weakness is, and then how do we resolve that? Well, we ensure all data in transit is encrypted using a secure TLS channel. We verify all data in transit is encrypted using a secure TLS channel. Is it done? Who did it? When? And has it been verified through maybe our integrations with scanning tools, for example? This makes it really easy for you to understand the current security posture of your project so that if you have to sign off on something like, hey, we know what is what threats exist and what weaknesses could potentially be exploited, and here's what we're doing about it. You have one document that proves it, and you saw how quickly that report was created. That took like 4 seconds for that to generate. Super, super easy. On a similar token, you can also present this same information in the context of a regulatory driver, of a compliance regulation. So when I go to the compliance reporting, for example, I can actually choose, we have about 50 of these mapped out of the box today. I can type in the NIST EO critical software regulation, right? Now, I can do, at this point, I could do one of two things. I could either go call up a big four consulting firm and say, hey, I need your help figuring out what are the requirements that need to be in place, or what are the things that I need to be aware of to make sure that I don't fall out of compliance with this executive order. Or I can open SD Elements and I can click the download button, and in 5 seconds, I can understand exactly what that looks like section by section in the exact language that auditors use. So for example, section SM 1.2, uniquely identify and authenticate each service attempting to access EO critical software. Here are the countermeasures from SD Elements that we need to complete in order to satisfy that. So instead of having these big, lengthy audit prep processes or bringing in third parties and paying them gold bars to figure out what you need to do for each application, SD Elements is going to automate that for you. And you can understand your posture at any time. If you have an audit coming in a week or two, run this report. It's going to tell you exactly how ready you are. And it's also going to show you what are the tasks that SD Elements knows about, but aren't in scope for this project. Negative attestation is really important, especially with NIST audits. So this is very, very helpful. And frankly, there's really nothing else on the market that does this. Super exciting stuff. So anytime you are trying to figure out what your next steps are, or where you even start from a compliance perspective, whether it's the executive order, PCI, GDPR, NIST 853, FedRAMP, I could go on. SD Elements is the answer. SD Elements is where you start with this. Now that's a report at the project level. The last thing I'm going to leave you with is a report that's at the organization level. So we have the ability to create dashboards, for example, that are going to show the compliance of the various applications across our portfolio, and how ready we are for different compliance regulations. So if we wanted to create a dashboard that was just looking at the executive order compliance and how close are we want to segment that by business unit, by team, by project, by tag. There's a lot of very powerful reporting functionality that allows us to understand where our risk lies and where we might need to focus our attention. We would love to get into kind of something that's a little bit more custom tailored for your organization and what you do. We can show you what dashboards are going to be meaningful for you. So I think that's probably a good next step. Is we'd love to have a chat about where this can fit into your organization, help you scale your threat modeling, and help you start meeting that new executive order as well as other compliance regulations that your business has to follow today. So with that, I'm going to turn it back over to Drew, and thanks for watching.
Awesome. Thanks, Kevin. Let me share. All right. And before we take some questions, we're going to talk a little bit about our customers. So who are our customers? 17 of the largest banks and financial service companies in North America and Latin America. 13 of the largest technology companies, including software, chip makers, and payment processing companies. Major U.S. federal government agencies, including the FBI, the Department of Veteran Affairs, the U.S. Department of Defense, the U.S. Navy, the U.S. Army, and the U.S. SEC, and of course, numerous clients in other critical industries. Always like to show this slide. We have the privilege of working with some really great customers, and they have some really great things to say about their experience working with us. From Jeremy over at FINRA, SD Elements enabled FINRA to achieve rapid self-service engagement model to rebuild and scale FINRA's threat modeling capabilities to the entire application portfolio, regardless of the size or complexity of any given application. Brian over at Johnson Controls, our security champions and development teams saw firsthand how easily they can quickly receive a tailored set of security requirements and clear development guidance. Since using SD Elements in their product development work, they've been shipping secure products with reduced time to market. And finally, Conrad over at Cubic, SD Elements is the best solution to improve cyber resilience. It helps ensure security is built in and considered at every stage of the software development. SD Elements provides the guidance needed to produce secure software. Also want to take a moment to highlight the total economic impact study that Forrester did with us a bit ago. It is on our website, link here. We'll send this presentation out before, but ROI is around 332% payback under 6 months. That will vary from organization to organization, but there is a lot of power in collaboration and automation in a platform like ours. All right, I think that is time now for Q&A. Maureen, do we have any questions from the audience?
All right. Okay. Yes, we have had a few questions come in. Thank you, Drew. Thank you, Kevin. A couple folks have already submitted questions, so I'll start with those. And for others, if you want to ask a question, just go ahead and type it in the question in your comment box. We'll try and get through them all. So let me pick one out here. A lot of questions, I think, Kevin, a little bit of a follow-on to some of the things that you talked about. So I think the first one we'll start with is, how exactly does SD Elements identify software threats during the software development process?
Yeah, so we have, over the last 10 years of building this product, we have developed a very intelligent logic engine that allows the various characteristics that SD Elements learns about your application and how it's built, and the programming languages and frameworks that it's built upon, the features and functions, how it interacts with other systems. We've got a pretty complex logic engine that is powered by a very, very large content library of expert researched content that ultimately provides actionable guidance to developers. It's one thing to identify threats and identify what the threats and weaknesses are. It's another to actually do something about them and provide actionable guidance on how to make sure that threat doesn't get exploited. So really the identification process is all done by our logic engine. And really the way we get real results with threat modeling is by how actionable our content is.
Okay, great. And Kevin, the next one is around prioritization, and it's how does SD Elements prioritize the threats or weaknesses that have been identified during the threat modeling process, so developers know kind of which ones are the most important or where they should focus first?
It's a great question. So first of all, the block of tasks that you work with starts with that classification and risk policy that I identified. So for example, if you're developing some small internal utility that is not handling customer data, it's not touching the internet, most organizations will treat that with a little bit less rigor than their core application that handles customer data. So having SD Elements drive the classification of those apps that then determines the minimum bar to work with is the first step. The second is we've applied the pretty commonly accepted principles from CAPEC and from the Common Weakness Scoring System from MITRE to the threats and weaknesses that we've identified. Customers do have the opportunity to override those with their own priority values if they want, if there's something that they want to adjust, like to us, for example, this is a priority 9 instead of a priority 7. They have the flexibility to do that. So it's quite flexible, but we've mapped to known good industry standards as part of our out-of-the-box offering.
Okay. And sorry to keep hitting you with these, Kevin, but I think this next question is kind of related, and maybe partially you answered just a second ago with your response, but what threat intelligence or threat library or libraries does SD Elements use? I know you mentioned CAPEC and stuff already. So.
Yeah, so Stride and CAPEC are two big ones. We've also they're not really threat intelligence libraries, but we have mapped out to different standards that people that other organizations have kind of held themselves to, whether that's the oh my gosh, I'm blanking here. The common oh my goodness, the common controls matrix, the web controls matrix, CCM. Sorry, wow. CCM is a big one. The CIS benchmark is another big one that we've mapped out to. So organizations that have already aligned to something like that will see a lot of familiar kind of mappings with how we've organized our content and how we report on it.
Yes, and then I think you just touched on this, but to ask maybe a little bit more explicitly, what threat modeling methodology does SD Elements use?
So SD Elements employs like a developer-centric threat modeling. Again, we do map to Stride. So if you are used to doing SD Elements in a Stride capacity, as I showed in the demo, like all of our content is mapped out that way. But our focus is really on the scalability and actionability of the threat model, and that that kind of goes against some traditional ways of looking at the process. So we believe that focusing on the developer, who are the people that ultimately have the ability to affect meaningful change in the security posture of their app, they're the ones writing the code, they're the ones defending the system, not finding the flaws afterwards. By focusing on the developers, we believe we can make threat modeling a lot more effective, and our customers definitely agree.
Okay, great. And I just realized I'm throwing all these questions at Kevin. So Drew, I'm gonna throw a couple
All right.
We've got about 3 more in the queue here. How long does it take to generate a threat model?
Yeah, I mean, it does vary a little bit depending on what you're trying to do, right? I mean, so for instance, if you were trying to baseline an entire system, we could be talking, it takes a little bit longer, but that's not actually what we recommend. We actually recommend kind of doing this during a team's kind of new work intake process, right? And so you're really focusing on what are we working on now, right? And really kind of threat modeling the delta and the components that are being changed, et cetera. And when we're doing it this way, like you're arriving at threats and countermeasures within minutes, not hours. There really is something that you can build into the normal way that you're working on and designing software.
Okay, great. And as a follow-on to that, Drew, how often are the software threat models SD Elements generates updated? I know you just talked about starting out with an intake model, but once you have one built out.
Yep, absolutely. It varies by organization, right? So some organizations might be on a more of like a quarterly release sort of thing. They might be doing it, 4 times a year. Again, probably not as common. We would really be looking at, a lot of Scrum teams kind of working in 2-week increments. But it's really as often as you want. The team can update it anytime they would like.
Okay, and last question, as we start wrapping things up, maybe Kevin, if you don't mind, where are the threat models that SD Elements generates? Where are they stored?
So they're stored within the models themselves are stored within the SD Elements database, but they are very easy to export if you want to take them out as a JSON or a PNG, or you want to pull them out through our API and integrate them with other systems. It's very easy to do that. And as we saw, I mean, the countermeasures, which are really the things that are going to make the meaningful difference in the security of the software, those get stored in the issue tracker as well. So there's always going to be a record of them when the developer attests to completing it, or we have results from code scanning tools, for example. You're always going to have the record of that for traceability purposes, for you to be able to go back and see what were the threats we identified and what did we do about it.
Okay, great. So with that, it looks like we've handled pretty much all of the questions. So we'll go ahead and wrap things up. So in terms of next steps, you can learn more about SD Elements by visiting our website. We have a lot of resources out there, such as case studies, even more in-depth case studies from, FINRA and JCI and Cubic that Drew alluded to in his part where he was talking about our customers. We've got explainer videos and demo videos and lots of good white papers and research reports. And they're all really designed to help you understand how customers are using SD Elements today to model software threats and deliver secure compliant code quickly. In addition, as you can see here, if you want to learn more about the quantifiable benefits SD Elements has delivered, check out this report from Forrester. We commissioned Forrester to do an independent third-party research report where they interviewed our customers, and our customers talked directly to Forrester about the value and quantification of the value that they've seen using SD Elements within their own organization. And certainly not last, but certainly not least, if you've got more questions or you'd like to learn more about SD Elements or see a customized demo or explore how you might be able to use SD Elements in your own organization to speed up software threat modeling and threat remediation, or perhaps to help you comply with some of the new requirements from the executive order,